Hello everyone, today let's solve the problem number 371, sum of two integers. So here, given two integers a and b, we have to return the sum of the two integers without using the plus and this one, addition and subtraction operator. They have clearly mentioned here, plus and minus. So here, given two integers a and b, we have to return the sum of two integers without using the operators, this one, addition as well as the subtraction operator, means plus and minus. So here you can clearly see a we have been given 1, b we have been given 2. When we sum up this one, we have to get the output 3. And here same goes with the example 2 as well. A we have been given 2, b we have been given 3. So the output that we need to get here is 2 plus 3, nothing but the sum we have to get here as 5. So I hope the question is completely clear. What we need to do is completely clear as well, right? So first let's discuss the approach, and then let's write the code and discuss the complexities for the code that we have written. First, as usual, let's discuss the approach. So the approach that we'll be going with here is bit manipulation. So the approach that we'll be going with here is bit manipulation, right? So this is nothing but XOR plus carry simulation. XOR plus carry simulation. Means we'll be mainly going with the XOR and carry simulation, right? So I have considered the same first example that they have given in the question. So this will be easier to understand. The output is 3. When we sum up 1 plus 2, a and b, this has to lead us 3. This has to lead to 3, right? So here in this case, 1 plus 2, this is fine. We shouldn't be making use of the plus and minus operator, right? Let's see what's the approach we'll be going with. Basically, let's go with the step-by-step explanation. First example itself I have considered a equals 1, b equals 2 here. So first what we will do, we will convert this one to the binary. A in 1 in binary is 0, 0, 1. B 2 in binary is 0, 1, 0, right? 0, 0, 1 and 0, 1, 0. This is 1 and 2 in binary, right? So carry, for the carry, what we'll be doing, we will be going with the, we'll be performing bitwise AND here in this case. So just remember bitwise AND. Only when there are two ones, then only we will get 1. Else all the operations, else for all the operations we will get 0 itself. Only when we have two ones, then only we'll get 1. Else for all the operations we will be getting 0 itself when we perform bitwise AND. Here this one, left shift operator, so we are moving the rightmost significant bit, this one, by 1, and we will be adding that one to the left, right? So that's what we will be doing by making use of the left shift operator, double left shift operator here. So see here, a and b we are doing first. So here in this case we have got 0, 0, 1 and 0, 1, 0, right? So we don't have two ones at all. 1, 0 we have, this will lead to 0. 0, 1 we have, this will lead to 0. 0, 0, this will also lead to 0. Only when we have two ones, then only we'll get 1, right? For the when we perform bitwise AND. So here in this case we got 0, 0, 0. So 0, 0, 0, we are performing left shift operation here. Left shift operation, right? We are making use of the double left shift operator here on this case. So here what happens is, as we have 0, it does not make any impact here. So if we move this one to here at the beginning as well, if we remove this one and move to the left side also, it doesn't make any impact, right? So in this case it will be 0, 0, 0 itself. So let's perform the XOR operation on 1 and 2. Now we are done with the bitwise AND and this one, right? And performing the what do you call, left shift operator here. So now let's perform XOR. So 0, 0, 1 and 0, 1, 0 we have. Only when we have different numbers, different digits, then only we will get 1, else 0. Here in this case, when I say different digits, 1, 0 or 0, 1, then only we get 1, else we will get 0. For 1, 0 we get 1. For 1, 0, 1 we get 1. For 0, 0 we will be having 0 itself. We are performing XOR operation right here. So the output that we got here is 0, 1, 1. So 0, 1, 1, when it converted to this one integer as 3. When we convert 0, 1, 1 to integer, it is 3, right? So we got 3 here. So carry is 0. As we have got 3, there is no carry. So carry is 0 here on this, right? Loop ends here. Why the loop ends here? Because we don't have any carry, right? Carry is 0 itself here in this case. So as b is 0, as b and carry are same, as b is 0, loop ends here, and the output that we got here is a equals 3. Here you can clearly see when we performed the second step. when we performed XOR operation here in this case for 1 and 2. So we got here as 0, 1, 1, nothing but this is 3 in the integer. So the final result that we got here as a equals 3, or we can just give 3 here. 3 is the output that we got, which is equivalent to the output that they have given for the first example in the question. So successfully we have got the output 3, right? So without performing, without making use of this one addition and the subtraction operator, we can just go with the bit manipulation, XOR plus carry simulation, to get the desired output. So this is the way basically, right? So now I hope the approach is completely clear. As we are completely familiar with the approach, now we are good to write the code. Let's start writing the code. So the first step what we will be doing here is let's get the length of the array. Range is from 0 to n, right? So I'll just go with here int n equals dot length. This is fine. So sorry, so we don't have any array, right? So what am I doing here? I got confused with the problem that I was solving. Sorry. So here the first step here is we have to loop until there is no carry left. Means let's perform the while loop here. Let's go with the while loop here. We have to loop until there is no carry left, right? So I'll just go with here when we performed XOR operation until b was 0, means carry was 0 in this case. So that is how we got the output 3a equals 3. That's what we returned here, right? So that's what we'll be doing here in this case, if you remember. Sorry, I just got confused with the last problem I solved. So I'll just write the code here. While within the while loop, what we'll be doing? So here carry will store the common set bits of a and b, and that will be shifted left by 1. We have seen this one, we have performed this one, and we have seen this one. So I'll just write here. That's what we'll be articulating the same thing in the form of code here. So I'll just go with a and b. So here in this case, left shift 1. This is fine. The next step here is XOR basically calculates sum without the carry, right? So without the carry, XOR will basically calculate the sum. So I can just write here a XOR b, right? This is fine. The next step is we have to assign the carry to b for the next iteration, right? I'll just assign the carry to b here in this case, in this way. This is fine. So final step is when b is 0, a contains the final sum. We know this one through the approach, right? So let's return a here in this case. When b is 0, a contains the final sum, nothing but we have to return a in this case accordingly with the approach we have written a here. Let me run the code. So I hope this works. Let's see. So let me enlarge this one. So yeah, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is bit manipulation, means XOR plus carry simulation, right? So that we went with the approach that we went with is basically XOR plus carry simulation. We can just call this one bit manipulation. This is fine. We know this. So what would be the time complexity here? The overall time complexity would be big of 1, because the input is 32-bit signed integer here. You can clearly see. Let me hit the description here. You can clearly see the input is 32-bit signed integer, right? So operations are constant in number. So time complexity, overall time complexity would be quite obviously big of 1 in this case, right? So what would be the space complexity here? The overall space complexity would be big of 1 as well. So why it is big of 1 here in this case? Because we are making use of only few variables, right, for the computation. So which is basically of the constant space. So overall space complexity would be quite obviously big of 1 in this case, right? So the time complexity for the code that we have written is big of 1, and the space complexity is big of 1 as well. So I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.